And welcome back to my channel. In this video, we'll be continuing from where we stopped from the last one, where we did a practice video on SQL joins. So if you are seeing my screen, I believe you are. Yeah. Okay. So if you see my screen, we have so far we have done the select statement from where you draw from a table, where statement. And in the last video, we talked about joins, the different kinds of joins, and the joins come in as an extension from the as an extension for the from statement, as you can see on this diagram. I think I should make this larger. So this is the from statement. We extend it using the various kinds of joins. So for every topic we have treated, we have also done like a practice with me video where we ran different queries, SQL queries, focusing on the different topics we have gone through. So in this today's video, we are going to go a little bit forward from joins. We're going to be talking about SQL operations, different SQL operations. So this is the point where we are going to be focusing on today. These operators expect two or more complete SQL queries as operands. So for today, we are going to be looking at three operators and an extension of under three. So we are going to be looking at union, intersect, and except. Would also talk briefly about union all. That's under operate. That's under operator. Union all, intersect all, and except all. So let's dive right in. So as I said, the first operator we'll be looking at right now would be the union operator. So what the union operator does in the union operation is that it combines the result of two queries by concatenating all their rows together into a single result set. Now, does this always make sense? Not always, right? But sometimes it's good you know this kind of operations exist, because who knows, you might need to use it. So, um, but there is something really important I would like to mention. There is such a thing as union compatibility. So union only works if both input tables have the same number of columns and a corresponding columns have the same domain types. That's the same data type, right? So any pair of tables that have both of these qualities are said to be union compatible. The other operators, the intersect and the except, they also require that their inputs are union compatible. So if two tables are union compatible, they are also intersect compatible and except compatible. Okay, let's grab a quick example. That's So I have this data set online shop. Uh, where is that? Yep, online shop. It's up on my Kaggle account. I will put in the link at the in the description part of this video. In previous videos, we already talked about how to download datasets, create tables first of all, download datasets into these different download datasets and import them into these different tables you have created. If you're not so sure how to get this done, please refer to earlier videos. We talked about this in more detail. So I'm going to, first of all, let's check that the two different tables from these two different select statements, let's check that they are union compatible. Customer ID, they are all integers. Order ID and written, they are also integers, right? So we have this coming out from the orders table, and I think, yeah, this is the orders table. It has four columns: order ID, order date, customer ID, and total price. And the rating is like a rating of 1 star, 2 star, 3 star, just like that. So they are just integers as well. So we find out that when we run this, we have 15,553 records, right? Column customer ID integer, other ID integer. So um, when you combine this result with this result, you get this resultant, right? So let's also talk about the difference between union and union all. So what union does is it tries to return unique records. So that means if we had for customer ID 3006 and order ID 1 appearing in both this table and this table, if we had those appearing in the two tables, in the resultant table that has the union, it would appear only once. But for union all still combines them and duplicates as well. So if you do not want duplicates, you use union. But if you want duplicates, you use union all. So let's add all at this point, union all. And when we run this, you see that we have an increase in number of rows. Now we have 16,106 rows. This goes to show that some rows in this data are being repeated. Just because union all maintains duplicates. So union eliminates duplicates, union all maintains duplicate. So let's think about intersect. Intersect will only return those rows that appear in both inputs. So if you're familiar with the Venn diagram or set operations in mathematics, it's the same idea. Union, in this case, does exactly what union does in Venn diagram situation, right? Intersect too. The point, it gives you data that are present in both tables. So you just want to change this to intersect. So once you change that to intersect and you run it, let's see. Oh, we don't have rows that appear in this table and in this table. But if we did, I'm sure we will when we remove, let's say we remove written and we remove order ID, right? They're still union compatible, right? Because the same number of columns, one column, and the same domain. So when you run this, yes, we have 553 at the intersect. So 553 customer IDs from the other table and 500 at the same 553 customer IDs that gave reviews. So I hope you can interpret this really. So if somebody ran this kind of query, it means they want to find customers by their ID who gave reviews and who made some kind of order. So customers that ordered and gave reviews. So this would be it, right? Okay. So remember I talked about union compatibility. If we, let's say this has two columns and this has one column now, we find out that this would not work. You see, it gives you an error, right? And remember I also said if we have union compatibility, then we have intersect compatibility and accept compatibility, right? So let's find another data type column from the reviews table. So this is the reviews table. When you check the column, I think, yeah, review text is in text form. So let's check that. So we have review text. When you run this, yes, I expect an error. And that error is because, just as it says here, integer and text cannot be matched. So I'm just emphasizing for union compatibility, we want the same number of columns, and we want corresponding columns to be in the same domain or to have the same data type. So lastly, let's just talk about except. The except operation. Let's put this except. So what the except operation does is it takes all the row from the first input, that would be this table. It looks at all the row. Let's change this back to rating. So it looks at all the rows from this first table, and then it removes any of those that also appear in the second table. So it's like doing minus, right? Subtraction. It looks at everything in table A and then it goes through table B. If it finds something in table B that is in table A, it removes it. Does that make sense? I guess. Yeah. So let's run this to see whether that's. Oh, we have a lot of them. We have about 15,000 of them. So the result we have now of customers who placed orders but did not write reviews, if that makes sense. So the union basically would be customers who placed orders and customers who rated the items that they bought. The thing is, in real life, customers who gave ratings also placed orders, right? So for the Intersect, that will be customers who bought something, right? Who had other IDs. That means they bought something and then gave a rating, right? Then for the accept, those will be customers who bought something because they have an order ID, but even though they bought something, they did not give reviews. So um, just reiterating, customers who bought something. Then we go through customers who gave reviews. If we find those who bought something within those who gave reviews, we remove them, right? So what we have here are just customers that did not give reviews. Customers who bought something minus those that gave reviews. Just think about it like that, like subtraction. So we also have other operators like, just like I mentioned, union all, there is intersect all, there is except all, there is except distinct. And again, I would like to mention that all of this depends on the flavor of SQL you're writing. We're using PSQL, so you'd have to read and understand the documentation for whatever flavor you are writing. I'm going to end this video here. It's a super short video. In our next video, we'll talk about group by, having, and order by. That will be these ones in red here. We'll talk about them. So, see you on the next one. If you haven't subscribed, please do subscribe. It's totally free.